Hello everyone, and this is one more example related to link power budget calculation. And this question, the different losses occurring in the optical fiber link is given. So the total output power is 5 dB, coupling loss is 3 dB, connector loss is 2 dB, and 50 splices of 1.1 dB loss. So 50 into 0.1, so the total is 0.5 dB. So we have calculated connector loss for these 50 splices, and all other losses are written as it is, and the fiber attenuation loss is given 35 dB. So total loss is 35 dB. So these are the given quantity. So first we have calculated what is the total loss. So it comes 35 dB. Then total output power is 5 dB. So what is the available power to the receiver? So total output power minus total loss. This will give the available power to the receiver, and it is around minus 35 dB. Now next, the receiver sensitivity is given as minus 40 dB given. So what will be the loss margin? This is calculated by the receiver sensitivity minus available power to the receiver. So minus 40 minus 30 dB. So it comes around 10 dB. Now, so we have calculated the loss margin for this first case. Now, if the hybrid high impedance receiver with sensitivity minus 32 dB is, then what will be the loss? That is minus 32 minus of this available power to receiver. So this will give loss margin of 2 dB. So this is another example of to calculate the losses, link power losses with given losses and output power. So what we have seen that in link power budget calculation, we are considering the different components like slices, connectors, optical fiber losses in the calculation of power budget. But in case of rise time budget calculation, we are not considering all these components. So, but rise time budget is also important for the initial system design because it determines the dispersion limitation of any optical fiber link. So with the link power budget calculation, we have to calculate the rise time budget also. And the total rise time of fiber link is given by this formula, that is root sum square of rise time of each contributor of pulse rise time degradation. So this is the formula to calculate the rise time, and this must be low in order to meet the bandwidth requirement of the system. And rise time and fall time determines the overall response time and resulting in the band. Here here as we already discussed that connector couplers and splices do not affect the system speed and not accounted in rise time budget calculation. So for basic elements that contribute to rise time are transmitter rise time, group velocity dispersion, receiver rise time, and bandwidth of the receiver, VRX. VRX is a bandwidth of the receiver. So rise time due to modal dispersion is given by T mod 440 divided by Bm, and Bm is the bandwidth. L is the length of fiber and Q is the parameter ranging in between 0.5 to 1, and B0 is the bandwidth of 1 kilometer length fiber. So this is the formula to calculate the rise time, and this is the formula to calculate the rise time of overall system. Now next, receiver front end rise time is calculated using TRX is equal to 350 by BRX. This is the receiver bandwidth. BRX is the receiver bandwidth. And if we put the value in the these value in the formula, given formula, then the total rise time will be given by this. So if we talk about the numerical, then in numerical, different parameters will be given, and you have to use above discussed formula. These are the main formulas. On the basis of these formula, you can calculate the value of price time.